Today's lesson is rational and irrational numbers. Our goal is that we can work with irrational numbers. So this made sense to me when I was younger, when people, we talked about whole numbers, we talked about integers, we talked about irrational numbers, and then we talked about irrational numbers, and I never got how all those numbers fit together. So then somewhere along the way I saw this picture of whole numbers, and then integers, and then rational numbers, and then irrational numbers goes around the outside of this. So, but this kind of encompassed this and made sense to me when I was younger, and I just thought you guys might like to see that visual. Okay, so rational numbers. Definition. A number that can be written as a fraction, a over b, where a and b are integers and b is not 0. Okay, so think about that. Numbers that can be written as a fraction, where a and b are integers and b is not 0. In other words, a number that either terminates or repeats. Examples, -14 can be considered rational. 3/10 repeating. The cubed root of 729. The answer to the last one, by the way, is 9, in case you were wondering. Moving on. So we look at irrational numbers. The definition of this is the numbers that cannot be written as the quotient of 2 integers. In other words, a number that does not terminate or repeat. The square root of n is irrational if it is not a perfect square. So think about that. Perfect squares, we've studied these. Square root of 4, square root of 9, square root of 25, square root of 15, square root of 16 is 4, square root of 15 is going to be some yucky number. I like the word yucky, by the way, for that. That's a great descriptor. Pi. You guys, I'm sure by this point, know that pi is this ridiculous number that, we simplify down to 3.14 for working with it in our purposes a lot of times. But it goes on to this just number that just repeats or not even repeats, just goes on and on and on. If you put in your calculator, you get this ridiculous number. And then the square root of 122. Well, the square root of 121 is 11, but the square root of 121 is going to be 11 point something, and it's going to be yucky again. So, again, yucky, good word. All right, we're going to do some examples. Okay, so we're going to determine if these expressions are rational or irrational. The square root, the radical sign, works as a grouping symbol. So we're going to do what's underneath the radical first. So we're going to first square 9. So we get 81 plus 5 squared is 25. Okay, so 81 plus 25. Okay, this gives us, this is still under this, by the way, this gives us, we're going to move it up here, 106. 106 is not a perfect square. This means it is irrational. Okay? All right, our next problem. And again, you guys know you should be writing these down in your examples. All right, so we've got a squared, which is 4. So we're going to substitute everything in. So we get 4 squared plus 8 squared plus 1 squared. All right, so we get 16, not squared again, 16 plus 64 plus 1, still under the square root. Okay, when we add those together, we get 81 The square root of 81, we're going to take this over here because I'm running out of space, is 9, and this is rational. Okay, so this is our lesson. And of course, you know, if you got confused and you go back and watch anything, pause, rewind, whatever. I should always say that at the beginning, and I keep putting it at the end. Sorry, folks. Anyway, bring any questions you still have to class. We'll talk about them tomorrow or next time we see each other. I hope you enjoyed our lesson. Until next time.